Hello everyone and welcome back to another video. Today we're going to continue on with our rational expressions and rational equations outcome. First thing I want to do is just apologize real quick because I know the audio quality isn't going to be so great. You're going to hear lots of popping noises just because I'm using my phone as my microphone. So I do apologize in advance. So we'll see how today's video goes. So with our first question that we're going to take a look at first, we're looking at some complex rational expressions. And we want to be able to figure out what x is still. So essentially, we're just combining everything that we've done so far with adding and subtracting along with division. So the idea behind this is we're going to take a look at our fractions on the top and the bottom and figure out a common denominator so that we could add and subtract them and then finally divide them. So looking first at our fraction here on the top. So this first one, we have 1 over x plus 2. And we can see pretty quickly that our common denominator is going to have to be x. So let's go ahead and multiply the top and the bottom by x. And then when we switch to our bottom fraction, or bottom expression rather, we're going to have 1 over x minus 3, and we can pretend that's over 1. And once again, our common denominator here is going to be x, so I'm going to multiply the top and the bottom by x. Before we go any further, let's go ahead and write down our NPVs. So our NPVs, we can see pretty quickly that x cannot equal to 0. So before I can actually divide them, let's go ahead and add our top expressions together. So we have 1 over x plus 2x over x. And then on the bottom, we have 1 over x minus 3x over x. Once we're at that point, we can go ahead and combine our numerators together. So we have 1 plus 2x divided by x. And that's all divided by 1 over x minus, oops, let me erase that, 1 minus 3x, and that's over x as well. So we don't have any new NPVs yet because we can see that x is still our denominator in both rationals there, so we don't have to worry too much about that. Excuse me. And from there, we're going to go ahead and rewrite this so that our fraction on top, 1 plus 2x over x, stays the same. But now instead of dividing by this bottom, right, instead of dividing by that bottom fraction, what we're going to do is we're now going to multiply, maybe I'll change that to black. We're going to multiply by the reciprocal of our bottom fractions. Now this becomes x over 1 minus 3x. So we're going to introduce one new NPV here. So we end up getting 1 minus 3x cannot equal to 0. 1 cannot equal to 3x when we add 3x to both sides. And we end up getting x cannot equal to 1/3 as our new NPV. And once we're at this point, we can go ahead, get rid of our common factors. I have an x on the top and the bottom. And we can simplify by writing 1 plus 2x over 1 minus 3x. And that gives us our final answer. For the next one here, I've just gone over and moved this onto a new page. So you can go ahead, pause the video, and try this one out, and we'll see if we end up at the same answer. Moving on to our next portion, we're going to look at certain rational expressions where our denominators are going to be binomials and trinomials. So typically what we're going to need to do first is, in order to find that LCD, we'll probably need to factor our denominators. And it'll be good for us to factor the numerators too when we're able to. So when we're looking at our first example here, 2 over x minus 3 and 5 over x plus 4, we can see that we have two separate factors here. They are not the same. So typically what happens in this case is we're just going to multiply our two factors together. So we'll multiply, first of all, the x minus 3 as our first portion of that LCD. And the next portion is going to be that second denominator. So we essentially are multiplying those two together. Now, the reason why we end up multiplying those two together is we can pretend that on the bottom, instead of having some sort of binomial, we can say we have 2 over 3. And then for the other one, we have 5 over 4 as an example. So between 3 and 4, well, in this case, we're going to have to multiply the two together to give us that LCD, which is going to be 12. Now, this isn't always necessarily the case. We could have something such as maybe 3 and 6 instead. And we can see that between 3 and 6, our lowest common multiple between 3 and 6 is just simply going to be 6. So we only change this rational on the left. But again, if we have two denominators that don't have anything in common, such as, let's say, 5 and 6 in this case, then our lowest common multiple will be the product of the two. Moving on to our next question, we have a new LCD in this case. We're going to multiply our two denominators together. We'll have x times x plus 4 as our lowest common denominator. For this next problem, you'll notice that we're going to factor out this bottom denominator. It is a simple trinomial. So let's go ahead and rewrite that. So we've got 5 over, and then on the bottom, we need two numbers that multiply to 2 and add up to -3. So in this case, we're going to have x minus 2, x minus 1 as our two factors on the bottom there. And then we can also rewrite the bottom of our second rational, which in this case we have 5 over, and this is going to be a difference of squares. I can factor this as x plus 2, and let me do that in blue. X plus 2 and x minus 2. So what we're going to see in this case is we need to look at what common factors we already have. So in this case, we have an x minus 2 in both already, so that's going to be part of our LCD. But we also need to make sure that we include everything else that we don't see in there. So you'll notice that we have an x minus 1 that needs to be included, as well as an x plus 2. And let me squeeze that in here. So got x minus 2, x minus 1, and then x plus 2. So all of that is going to be our lowest common denominator. For these next two questions, you can go ahead and pause the video and then unpause once you're done to check your work. For this next portion, we're going to add and subtract rationals with different denominators. So there's a few steps that we want to be able to follow while we're doing all of this. First of all, we're going to factor all of our denominators, find the LCD, write your equivalent rational expressions over the lowest common denominator, expand your numerators, add or subtract your numerators, factor them to see if anything will reduce. Then you can find your NPVs, and then we can simplify by reducing common factors. So in that list of steps, we had NPVs near the bottom. I typically do like to do NPVs as early as possible just to make sure that I don't miss any. So in these first couple of examples, we'll work through a few together. We're going to first identify our lowest common denominator. So in this example, our lowest common denominator, you'll see we have an x and then an x plus 4. So we're going to multiply those two together. And I'll move this up here so I have a bit more room. I'm also going to state my NPVs early on. So here you'll see from our first fraction, we'll have x cannot equal to 0. And then from our second rational at the bottom, we have x plus 4 cannot equal to 0. So x cannot equal to -4. So let's go ahead and multiply our numerator and denominator of each rational so that we have common denominators. So you'll see here for the binomial on the right, we are missing an x. So let's multiply the bottom by x and multiply the top by x. For our rational on the left, we're missing an x plus 4. So let's multiply the top and the bottom by x plus 4. So that leaves me with 5 times x plus 4 over x times x plus 4 plus 6x times x over x times x plus 4. So you can see now that our denominators are the same. We can simply just expand our numerators up top, and then we can add them together. So what this leaves us with is 5x plus 20 plus 6x squared. And let's divide that by x times x plus 4. So here we end up with a rather complex looking trinomial up top, 6x squared plus 5x plus 20 divided by x times x plus 4 on the bottom. The way that we're going to figure out if this can be factorable or not is we can actually look at our discriminant. So our discriminant, remember, is going to be b squared, and maybe I'll write that on the side here. I'm going to end up erasing our answer, but b squared minus 4ac. And we want to see the nature of our roots. So what we're trying to look for is we're going to see if this is greater than 0 or equal to 0, and then we're going to have at least one real root. Okay, so for us, in this case, we end up with 5 squared minus 4 times 6 times 20. So we get 25. And we're going to subtract, what is that? 24 times 20, 480. So we subtract 480, and we'll end up with a negative number, which means that we're not going to have any real roots. So we can actually go ahead and stop there because we're not going to have any solutions to this. So let's go ahead and erase that. And our final answer can just simply be 6x squared plus 5x plus 20 over x times x plus 4. For the second question, we're going to go ahead and find our LCD first. So in this case, our LCD is going to be our two factors multiplied with each other, so x minus 2 and x minus 5. And then our NPVs, we have NPVs of x cannot equal to 2 or positive 5. So let's go ahead and start to multiply both the top and the bottom. So in this case, I need an x minus 2 on the bottom, which means I also need an x minus 2 on top. I need an x minus 5 on the bottom, which means I need x minus 5 up top. So we'll end up with x minus 5, x plus 3 for my one rational or one numerator on top. And I'm going to subtract this x minus 7, x minus 2 up top, and that's all over x minus 2, x minus 5. So I know we're going to be a little bit tight for room here. So for our first two binomials, when we multiply them together, we'll end up simplifying this as x squared. And that will be plus 3x minus 5x. That will be minus 2x minus 15. And then for our second pair of binomials, so we're going to subtract whatever we have here inside of our brackets. So we have x squared, we're going to subtract 2x, subtract 7x, which gives me minus 9x. And then negative 7 times negative 2 gives me positive 14. And again, that's all divided by x minus 2, x minus 5. So from here, we can start to get rid of some common, or combine our like terms, rather. So our x squareds will end up canceling out. We'll have negative 2x minus a negative 9x. So that's negative 2x plus 9x. That gives me 7x. Then I have negative 15 minus a positive 14, which gives me minus 29. And I divide that by x minus 2, x minus 5, and that will give me my final answer. For this question here, you can see that we can actually rewrite the bottom of this fraction as negative. We can factor out a negative, and I'll be x minus 3 inside of the brackets, which we can actually move this negative up top as well. So this can actually become negative 4 over x minus 3 on the bottom, which means that we have an LCD of x minus 3. For these next 4 questions, you can go ahead and pause the video and then unpause to check your work. Now we're going to move on to solving rational equations. Now the steps seen here are just one way of doing it, so I'll show you a second way that I personally prefer a little bit better. So here the steps state that you should be multiplying both sides of your equation by the lowest common denominator, and then we're going to solve your equation by isolating the variable. And then we can verify our solutions by substituting our answer back into the original equation. So we'll solve it first by figuring out what our LCD is and then multiplying both sides by the LCD. So I'll show you that method, and then I'll show you one that I personally like a little bit more just because I think it makes things a little bit easier visually. So for us, between 3, 4, and 6, we can see pretty quickly that our LCD is going to be 12. So we can multiply both sides of this equation by 12. So what's going to happen is I can multiply both sides by 12. So that means I have 12 times 2x over 3. So that gives me 24x over 3. Now I have 12 times 1 over 4, which is 12 over 4. And then I have 12 times 5 over 6. So 12 times 5 gives me 60, and I have 60 over 6. Now what happens for us is we can get rid of, or we can simplify some of our rationals here. So 24x over 3 gives me 8x. 12 over 4 gives me plus 3. And 60 over 6 is equal to 10. From here, I can solve this pretty quickly. I get 8x is equal to 7. And then from here, x is equal to 7 over 8. Now I'm going to go ahead and show us a second method that we can use. Sometimes people like this one better. Sometimes they like it a little bit less. So I'm going to go ahead and rewrite the original equation. So 2x over 3 plus 1/4 is equal to 5 over 6. Now method number 2 involves us trying to come up with a common denominator. So again, in this case, it means that we are multiplying or trying to get everything to equal to 12 on the bottom. So we can see that up top here for our first rational, we're going to multiply both the top and the bottom by 4 to give us 12 on the bottom. So we'll end up with 8x over 12. For our second fraction here, to get a denominator of 12, I multiply the top and the bottom by 3. So this gives me plus 3 over 12. And then last but not least, I need to multiply the top and the bottom by that last fraction to give us 10 over 12. And then all we need to do now is, now that we can see visually that we have the same denominator, we're going to multiply everything by 12. And what that allows us to do is that gets rid of all of our fractions, and we're left again with 8x plus 3 is equal to 10. So we end up with the exact same thing, but again, some people like doing this method a little bit more than the first method. And again, it's up to you to decide which one you enjoy more. So if we're going to verify our solution, we're going to substitute x is equal to 7 over 8. So now we're going to go through some examples of questions, and we're going to just put all of the concepts that we've covered together and just use that to help us figure out what our solutions are going to be. So we're going to make sure that we factor everything if necessary, find our NPVs. We're going to, again, if it's up to you, to multiply both sides of the equation by the LCD, or we can try to make each of our denominators the same. Then we're going to solve for our variable. If it's linear, we're just going to try to get x on one side. If it's quadratic, we're going to set our equation equal to 0. So that just means moving everything to one side. And then factoring, we're going to make sure that we compare our answers to our NPVs. And then we're going to verify our answers by substitution. So we can typically do this just mentally, unless it's stated that we need to show our work for verification. I'll verify for the first few examples, and then after that, I'll leave that to you to check on your own. So jumping right into it, let's go ahead and take a look at our first problem. We can see that nothing really needs to be factored. So I'm going to start off with my lowest common denominator. In this case, it's going to be 6x. We can see pretty quickly that our NPV is x cannot equal to 0. So for me, again, like I said, I personally prefer to have all of our denominators be the same thing. So in that case, if we're trying to make all of all of our denominators equal to 6x, I'm going to multiply the top here by 3, multiply the bottom by 3, multiply the top here by 2, and the bottom by 2. And over here, I'm going to multiply the top and the bottom by 3x. So what this leaves me with is 9 over 6x is equal to 8 over 6x minus 3x over 6x. Then I'm going to multiply everything by 6x, and that helps me get rid of my denominators. And now I'm left with 9 is equal to 8 minus 3x. I can subtract 8 from both sides, so minus 8, and that leaves me with 1 is equal to negative 3x. I divide both sides by negative 3, and I'll get negative 1/3 is equal to x. And we can verify our work by plugging in that negative 1/3 into our equation here. So maybe what I'll do is I'll pull this up on a calculator. So again, just a quick little shortcut here. We can set our solution here, negative 1/3. We can actually set that as, we can store our answer rather, as x. So this helps us out a little bit. So 3 divided by, and make sure you're using your brackets properly, 3 divided by 2x. That gives me negative 4.5 as our left-hand side. And then for our right-hand side, we're going to go ahead and do the same thing. So we've got 4 divided by bracket 3x, and close our bracket. And we're going to subtract 1/2. So let's go ahead and subtract 1/2. Subtract 1/2, and we get negative 4.5. So we have verified that the left-hand side is equal to the right-hand side. For this next question, we're going to start off with our LCD. So we need to make sure that we're factoring everything first, because we can notice, or we can see here that on the right-hand side, x squared minus 9x plus 18 can be factored. So we'll have 9 over x minus 3. And I'm actually going to change this top portion. I'm going to factor this as negative 4 over x minus 6. So again, if you're a little bit confused, you can go back to previous examples there where we can actually flip the sign and just have the negative come out on top. So I have minus 4 over x minus 6 on the bottom there. And then now you'll see in a second why I did that. For our denominator here on the right, I can factor this as x minus 6, x minus 3. So you can see already that our lowest common denominator is already appearing as part of 2 of our rationals. So x minus 3, x minus 6 will be our lowest common denominator. And since we factored everything, we can actually write down our NPVs. We have x minus 3, x cannot equal to 3, 6, and that's it, just 3 and 6. So from here, we can see that we are requiring an x minus 6 for our left-hand side there. And then over here on the right, we need x minus 3, x minus 3. We don't need to change anything on the right-hand side. So just rewriting everything, we have 9 times x minus 6 minus 4 times x minus 3. These are both over x minus 6, x minus 3 over x minus 6, x minus 3 is equal to 8 over x minus 6, x minus 3. And we're just going to multiply everything by our x minus 6, x minus 3, and that helps us get rid of all of our denominators. So let's go ahead and simplify things. So we've got 9 times x and 9 times negative 6. That gives me 9x minus 54. And I'm going to take the negative 4 times x, negative 4 times negative 3. That gives me negative 4x plus 12. And all of that is going to equal to 8. So let's go ahead and simplify. 9x minus 4x gives me 5x. Negative 54 plus 12 gives me negative 42, and that's equal to 8. I'll add 42 to both sides, so I'll get 50. And then I'll divide both sides by 5, and I'll get x is equal to 10. So if I were to go ahead and verify my answer here by plugging in x is equal to 10 back into my original here, I should get the same thing on the left-hand side of my equation as I'm getting for the right-hand side. So let's go ahead and work through two more questions together here. So we can see in this problem that the first and second fractions don't have anything that can be factored, but here in the third one, we can factor out a 3x. So let's go ahead and do that. We'll factor out the top as well. We might as well just do that. So 4x minus 1 over 3x minus x plus 7 over x minus 5. And that's going to be equal to, you can factor out a 2 here, 4x minus, and that's going to be a 5. And let's factor out that 3x, and we'll end up with an x minus 5. So from here, we can see our NPVs. So let's go ahead and write down our NPVs. So we've got 2 of them. From 3x, we get 3x cannot equal to 0, so x cannot equal to 0. That's my first NPV. My second NPV comes from the x minus 5. X minus 5 cannot equal to 0, so therefore x cannot equal to positive 5. So there are my two NPVs there. What we're going to do next is take a look at my LCD. So looking at my factors here, I've got a 3x and an x minus 5 and a 3x, x minus 5. It's pretty apparent that our LCD should be 3x and then x minus 5. So what we're going to do is multiply our rationals by whatever portion of the LCD isn't already there. So for this first rational, we're going to multiply everything by x minus 5. Maybe I'll do it on the left side here, x minus 5 on the bottom and x minus 5 up top. Over here for the second one, I'm going to multiply everything by 3x on the bottom and 3x on the top. And we don't need to move or change anything in this third rational. So what we're going to end up with, let's go ahead and expand so we can think of this as two binomials being multiplied with each other. I'm going to skip a couple steps and we're just going to go straight to 4x squared minus 21x plus 5 once we multiply these out. Then over here, we will end up subtracting 3x times x, that's minus 3x squared. And then we're going to subtract 3x times negative 7 in this case. Maybe I should clean that one up. I realize that this is quite messy looking, so let's make sure that is a minus 7. So let's make that minus 7. So down here, we're going to end up with a plus 21x. And then over here, we don't really have anything that needs to be changed, so we can actually just keep that as 8x minus 10. Once we get to this point, we're going to get rid of any or combine like terms. So we can see that we have a negative 21x plus 21x. Those will reduce. Then we've got our 4x squared minus 3x squared. That gives me an x squared. And then over here, I have a plus 5, and then that's equal to 8x minus 10. Moving everything over to the left-hand side, I'm going to end up with x squared minus 8x. And then I have a positive 5 minus, or rather plus 10. So I've got a plus 15 here, and that's going to be equal to 0. So we end up having to factor this out as x minus 3 times x minus 5, and that's equal to 0. Again, we could always use the quadratic formula as well. But from here, we get two answers. So we get x is equal to 3 and x is equal to 5. So right away, we can see the value of our NPVs here. So we already know that x cannot equal to 5. So I don't even need to worry about verifying this because we know it's not going to work because we've already stated that x cannot equal to 5 because that is one of the NPVs. So if we were to go ahead and plug this 3 back into our original equation, we would end up having this whole left side here be equal to the right-hand side, but I will leave that for you to check on your own. Let's take a look at this next one. I'm going to rewrite just this bottom portion here. We can see that this x squared minus 1 is a difference of squares. So I'm just going to rewrite this as x squared minus 17. I can't do anything with that one. But on the bottom, this is going to be x minus 1, x plus 1. All right, so let's start off with our NPVs. So we've got our NPVs of x cannot equal to plus or minus 1. And then for our LCD, it's just going to be x plus 1, x minus 1. So starting us off, we can see that we need to multiply the first irrational by x minus 1 on the bottom, and on the top, the second one, you need to multiply by x plus 1. And then this rational on the right-hand side is unchanged. So x minus 1 times 2x, what does that leave me with? I end up with a 2x squared minus 2x. I'm going to subtract 5 times x, which gives me negative 5x. Negative 5 times 1 gives me negative 5, and that's going to be equal to x squared minus 17. Combining all of our terms onto one side, I'm going to have 2x squared minus x squared gives me x squared. Negative 2x minus 5x gives me negative 7x. And then I'm going to have negative 5 plus 17. So I'm going to move that 17 over here. That gives me plus 12, and that's going to be equal to 0. And I end up factoring this as x minus 3x minus 4 is equal to 0. So I'll end up with two answers. X is equal to 3 and x is equal to 4. And both of these should work out once we verify our answers here. So now we're going to move on to applications of rationals. Typically, this is the portion of rationals that is the most difficult. Once we actually create situations and come up with our own equations, the process itself is not that difficult, but it's really just coming up with the equations, setting them up, and trying to figure out what your variables are going to be. That is the most difficult portion. So looking at our first example, we have two consecutive even numbers are going to be selected. The difference between the reciprocals of the two numbers is 1 over 60. We need to be able to find those two numbers. So the quickest way to do this is to first note some of our keywords. We have two consecutive even numbers. So remember, consecutive means one after the other. So for example, 1, 2, 3, 4, those are all consecutive numbers, but we're looking for consecutive even numbers. So if our first even number is 2, the next consecutive even number has to be 4. All right, so from here, what we're going to do is we need to define what our two numbers are going to be. First of all, we can say let the first number be 2x. So that's going to be my first number. I don't know what that number is, but in order to ensure that it's going to be an even number, it has to be 2 times whatever number it is. 2 times 5 gives us 10, which is even. 2 times 11 gives us 22, which is going to be even. The only way we can guarantee that it's an even number is if we add that parameter of whatever x is being multiplied by 2. We're going to let the second number be 2x plus 2. So we're going to make sure that our next number, we're just going to add 2 because we're already at one even number. To get to the next even number, we're just going to add 2. So going from there, we're going to move on to the next section. It says the difference between the reciprocals of the two numbers is 1 over 60. So we want to make sure that we understand what the reciprocals are. The reciprocal of 2x, we can think of this as 2x over 1. And for this guy, it's going to be 2x plus 2 over 1. The reciprocal just means that we're going to switch our numerator and our denominator. So now we have 1 over 2x as that reciprocal. And the reciprocal of 2x plus 2 is 1 over 2x plus 2. Since the difference is going to be a positive number, we're going to end up with our larger number being first. So in this case, 1 over 2x is bigger than 1 over 2x plus 2. So this means that we have 1 over 2x minus 1 over 2x plus 2 is going to be equal to 1 over 60. So if you're a little bit confused about why the 1 over 2x comes first, we can pretend that we have some numbers here. So if our bigger number, or rather our first number, is going to be 2 and our second number is 4, we can think of this as 1 over 2 minus 1/4. 1 over 2 is bigger. We know that's 0.5. And we're going to subtract 1/4, and that's going to be minus 0.25. If we switch these two numbers around, we would actually end up with a negative answer, which is what we don't want. We want to have a positive difference. So taking a look at our work here, once we get to this stage, the question is essentially done. It's a pretty straightforward rational equation to solve from here. We're going to first state our NPVs just so we're aware of what the possibilities are. So in this case, we're going to have 2. So 2x cannot equal to 0, so x cannot equal to 0. And from 2x plus 2 cannot equal to 0, we get 2x cannot equal to negative 2, so x cannot equal to negative 1. So I have two NPVs here, so we can go ahead and get started from here. My LCD in this case is going to be a little bit tricky to look at, but really, since we already have a 60 here and we have a lot of 2's, we're going to need a 60. We need to have an x, and we also need to end up factoring this out. Right here, we can factor this out as a 2 times x plus 1. So that means we also need an x plus 1 as part of our LCD. So for us, our next step here is to figure out what we're going to multiply everything by to get us to that same common denominator. So for this first rational, we're going to multiply by 30 times x plus 1. So what I do to the bottom, I also do to the top. And then for the second one, since I already have a 2 on the bottom, I'm just missing a 30. Whoops, let's do this. I'm missing a 30x. So what I do to the bottom, I do to the top as well. And then for this right-hand side, I'm missing an x and then x plus 1 like that. So x times x plus 1. It's a little messy, but let's go ahead and simplify. So 30 times x plus 1 times 1 is just going to be 30 times x plus 1. I'm going to subtract 30x times 1. That's just going to be 30x. And that's equal to 1 times x plus 1. I'm just going to simplify that first. X squared plus, oops, not 1, x squared plus x. We can see here, eventually we would get rid of our denominators. Our denominators here would end up being my LCD. I'm just going to skip the step for the interest of time. So we'd end up crossing these out in this step. So I'm just going to skip that in case you're wondering. So from here, we can go ahead and simplify. 30x plus 30 minus 30x is equal to x squared plus x. We can get rid of some of those common, or rather we can get rid of some of those like terms, 30x minus 30x. And let's move that 30 over to the other side. So let's subtract 30 from both sides, x squared plus x minus 30. We can factor this as x plus 6, x minus 5. So we end up with two answers. X is equal to negative 6, x is equal to positive 5. So here is the part where a lot of people get really confused and you're like, well, it doesn't make sense. We can't have 5 as an answer. And you're correct. We can't have 5 as an answer because that's not an even number. But remember, we have already defined our first number to be 2x. So let's go ahead and do this. When x is equal to 5, what happens is the first number ends up being 2 times 5, which is equal to 10. And your second number is going to be 2 times 5 plus 2, which is equal to 12. So you have 10 and 12 as your two numbers. When x is equal to negative 6, look at what happens here. Your first number is equal to 2 times negative 6, which is negative 12. And your second number is equal to 2 times negative 6 plus 2, which is equal to negative 10. So we have negative 12 and negative 10 as your two possibilities when x is equal to 6. So we actually have two sets of possible answers. 10 and 12, or you can have -12 and -10 as your two answers. For this next question, it says the average speed of an airplane is 8 times as fast as the average speed of a train to travel 1,200 kilometers. The train requires 14 hours more than the airplane. Determine the average speeds of the train and the airplane. We're going to use our two formulas. Distance is equal to rate times time. And then we have d is equal to distance over, this should be your rate, or distance over your speed, distance over your rate. So a chart is going to be really, really useful for these types of questions, especially these distance, speed, time types of problems. And what it does is it helps us kind of organize all of our information here. So first of all, if we're looking at the train, they're both going to travel 1,200 kilometers. So we can go ahead and write that down first. They both travel 1,200 kilometers. Their rate is going to be a little different. We already know here that the speed of an airplane is 8 times as fast as the speed of a train. So it's 8 times faster than the train. So if we know the train, and we're going to say that the speed of the train is x, and then that means that the speed of the airplane is going to be 8 times x, or just 8x. Using our time formula here, t is equal to d over r. Our time can be represented as 1,200 over x for the train and 1,200 over 8x for the airplane. So we want to be able to use the rest of this information here to help us figure things out. To travel 1,200 kilometers, the train requires 14 hours more than the airplane. So there's a few different ways we can actually express this information as part of an equation. But the one that we can go ahead and use here is we could say that let's do this. We could say that the time taken by the train minus the time taken by the plane is going to equal to 14, right? Because whatever amount of time, right? Let's say this is 20 hours, and then let's say the plane is taking 6 hours, it's going to equal to 14 hours. So whatever time you take with the train, we're going to subtract the time taken by the plane. That's going to equal to 14. Now, some of you guys might come up with different formulas. You could have time taken by the train is equal to 14 plus the time taken by the plane. That could also work as well. So it just really depends on how you want to set it up. As long as you have some sort of variation of this type of information, then we're going to be fine. So let's go ahead and solve this. So we have 1,200 over x minus 1,200 over 8x is going to be equal to 14. We can pretend that this is 14 over 1 just so we can figure out our common denominators a little bit easier. And we can see here that we're going to write down a few pieces of information. Your NPVs, x cannot equal to 0, so your speed cannot equal to 0, which makes sense. And your LCD in this case is going to be 8x. So we're just going to multiply everything by whatever we need. So in this case, 8 on both the top and the bottom. So we can hit that 8x as our denominator. So I'm going to multiply this right-hand side by 8x. And what we end up with is 9,600 minus 1,200. And that's going to equal to 112x. So again, once we find our common denominators, we'll end up getting rid of everything, right? So we can actually just go ahead and cross that out. And what happens is we're multiplying everything by 8x. So we have 8,400 is equal to 112x. We're going to divide both sides by 112. And we end up getting x is equal to 75. So if we look at our chart and we go ahead and plug in our value of x back into here, we have a train. So the train's speed is equal to 75 kilometers per hour. And then for the airplane's speed we know that's going to be 8 times 75, which gives us 600 kilometers per hour. For this next portion, it's actually a little bit easier to, you don't necessarily need to have a chart. I would actually just get rid of this part. I know some people like to use this part, but maybe even just the first two columns will be fine. So we have Emily takes 4 hours to paint a room. Selena takes 3 hours to paint the same room. How long will the paint job take if they work together? So it's important to see here that if we have Emily taking 4 hours to paint the room, the fraction of work that Emily gets done in 1 hour is actually going to be 1/4 of the total work, right? Because if it takes 4 hours, in 1 hour, they're doing 1 out of 4 hours of work. Same thing with Selena. She takes 3 hours. So doing the fraction of work in 1 hour, she does 1/3 of the total amount of work. And thus it follows that together we know that they take X hours. So the fraction of work that they do in 1 hour is actually just 1 over X. So from here, we can come to the conclusion, okay, that if we go 1 over Emily's time, so maybe you can write it like this, we can talk about Emily's part, Emily's work plus Selena's work equals work together, is how we can kind of take a look at this. So really we just have 1/4 plus 1/3 is equal to 1 over X, right? So this is how much work they're getting done, right, in 1 hour. So from here we have a couple things. We've got your NPV, X cannot equal to 0, your time can't equal to 0, right, which makes sense. And your LCD is just going to be 12X. So from here, it's pretty straightforward to see that we're just going to multiply this by 3, multiply that by 3, multiply this by 4, and then multiply this by 12 on the top and the bottom. We can get rid of our common denominators here. So we'll have 3 plus 4 is equal to 12. Oops. I'm forgetting some x's here. Let's add those x's. 3x. Getting a little bit late, getting a little bit sleepy. 3x up top, 4x on the bottom there. So we have 3x plus 4x is equal to 12. So 7x is equal to 12. So x is equal to 12 over 7 hours. So it takes them 12 over 7 hours to, what do we say they were doing? Painting a room. To paint a room together. For this next question, you can go ahead and pause the video, try it out, and check your work once you're done. For this last question, I actually want to do together because it does introduce the idea of having a current. So taking a look at this problem, we have to prevent grounding, a cruise ship anchors 18 kilometers away from a river port. To transport the passengers to the port, the crew uses smaller boats. These smaller boats can travel 12 kilometers downstream with the current in the same time it takes them to travel 8 kilometers upstream against the current. So the speed of the current is 6 kilometers per hour. Find the speed of the smaller boat without any current. Calculate the time it takes for the small boat, not the small bore. We're not taking a pig up the river. That's a small boat. To travel upstream 18 kilometers to the port. So let's go ahead and fill out our information here. So we know that downstream is with the current, So we're going to travel with a bit of extra speed. And then if we're going upstream, we're going against the current. So your distance downstream, we know it's going to be 12 kilometers, and your distance upstream, we said was 8 kilometers. The part that people typically struggle with here is the rate or your speed. We can say that your speed without any current, let's go ahead and do that. So we can say that let x equal speed without current. So without factoring in our current, we can just write X for both downstream and upstream. If we're moving downstream with the current, we're going to add that speed of the current, so X plus 6. So logically, if we're moving upstream against the current, we're going to count that 6 kilometers per hour against us, and that's going to actually lower our speed. So then going to our previous formula, we said that T was equal to D over your rate. So we have 12 over X plus 6 is your time. And then now we can see that our upstream time is going to be 8 over X minus 6. A few things that we need to note is that the key phrase that helps us figure out how to set up our equation is that the boats are going to take the exact same time going downstream as they are going upstream. So that means that your time going down is going to be the same as the time going up. So these happen at the same time. So we can say that 12 over X plus 6 has to be equal to 8 over X minus 6. From here, it follows we have two NPVs. X cannot equal to plus or minus 6. And your LCD is going to be X plus 6, X minus 6. So let's go ahead and find or multiply to get common denominators. So multiply by X minus 6 on the left-hand side and X plus 6 on the right-hand side. We can get rid of our common denominators. Let's start to multiply. X times 12 gives me 12X. Negative 6 times 12 gives me negative 72. On the right-hand side, 8 times X gives me 8X. 8 times 6 gives me plus 48. Let's start to move our like terms to one side. So let's move the X's first. I'm going to subtract 8X from both sides. We get 4X minus 72 is equal to 48. Let's add 72 to both sides. So we get 4X is equal to 120. And then finally divide both sides by 4. So we get X is equal to 30. So once we get to this point, we can go ahead and state the speed of the smaller boat. So you can say speed of boat without current is 30 kilometers per hour. And the second part it asks us to figure out is to calculate the time it takes for the smaller boat to travel upstream 18 kilometers. So again, we're just going to go back to our formula. T is equal to D over R. So time is equal to D over R. We said that we're traveling 18 kilometers. So time is equal to 18 kilometers over 30. So 18 over 30 gives us 0.74 or 75 hours. So really, we're just looking at 45 minutes. And we are all done. Once again, with these types of questions, it just takes a lot of practice because there are a whole bunch of different situations that we haven't explored here. There are ones where we have airplanes that have a tailwind. We have maybe someone jogging with or against the wind. There are a whole bunch of other situations with picking two integers that we can work with, painting rooms, cleaning houses. There's all different types of situations we could model with rational equations. If you have any questions, feel free to leave them in the comments section down below, and I will do my best to get back to you. Thanks again so much for watching, and I hope to see you in the next video.